I bought this old Stanley level at a yard sale. I thought it was kind of cool. It has a bubble indicator in the middle for horizontal, and it has two bubble indicators on the sides. Unfortunately, one of them is dried up, and maybe I could replace it at some point, but that's not really that important to me. What I was hoping to do is to take this old cast iron level and make it parallel to within maybe a tenth or so, and get the center bubble calibrated. So the first step of doing that would be to take a known flat surface. I'm using Joe's Mojave surface plate, and I blued it up. And what I did was I just made one side totally flat. Now the way that I did that is I did a technique called scraping. And when you scrape something, basically what you're doing is you're taking off all the high spots. So I'm going to see if I can do this with one hand. But basically what I did was I have a couple of scraping tools that I made, and they are here. And these tools are essentially carbide files that they were so dull that I couldn't use them anymore. And what I did was I sharpened the end with a 90-degree blade. Let me see if you can get an eye on that. But basically I put an edge on it, on the very edge, and I took off some of the edge so that there's no teeth on the end, and it gives me a perfect 90-degree blade that I can use for scraping. And the way this works is you just slide the blade across, and what you're doing is just taking off the high spots. You're just removing the blue, basically. And if you do this enough with a variety of sizes of blades, I have a medium-sized blade I made. It's a very long process, as you can see. And every time you scrape off like this, you actually are removing some metal. You're removing a tiny bit of metal. And after a while, you get to the point where your surface is kind of like this. You've got contact patches all along, and each contact patch is maybe less than a centimeter in size. And that is really to be considered quite flat. That's flat within about a tenth or one 10,000th of an inch flat. Then what I did is I took it on the surface grinder and I ground the other side completely parallel to this side. Then I ended up with a completely flat and parallel straight edge. So now the other side, which I ground on the grinding machine, is completely and utterly flat, as you can see. And I could theoretically take this back. I have one surface right there, it looks like it was bent, but I measured that and it's actually, like maybe a half a 10,000th or so, or a tenth or so. I'm not going to worry about that. For what I need this, to do checking heads and things like that is what I want to use this for. But now I've got two sides. I could have taken this back to the surface grinder and hit the other side, but I kind of like the scraped side. I like the look that it gives you. It's neat. So now the next step is I got to figure out how I'm going to calibrate the glass. I'm going to go search around for Joe's precision level, and I'm going to make sure his table is flat, and then we're going to get to the next step. Okay, so I've removed the level, the bubble, from the unit, and what I've discovered is that it has a ground flat surface on the bottom, which is out, basically. It's just not correct. It looks like it needs to be changed quite a bit, because if I get it back to 0, it's like, 3 or 4 millimeters off the ground, so I'm not sure why it's doing that. I'm not sure why it's doing that. Strange. I'm going to take it apart and see what's going on inside there. Okay, after a little bit more investigation, I removed the end caps on here, which are actually fairly low precision. You can see they've got a centering piece, a centering piece, and it's got an offset hole, which is not very high precision. And then inside is a piece of paper, and then the balance itself. So my goal here is going to be to get this as accurate as possible and on the level like this, on the flat side. And then when I put it into the level, it should be much more level. Let's see what happens here. So in addition to doing my level, I also brought in my rough surface plate, which is a chunk of aluminum that I made flat, and a couple of pieces of, I don't know what they are, they're parts of a machine that broke off at some point, and I made them into a set of parallels so that I don't have to use my nice parallels when I'm doing drilling or any other operation that requires me to raise something off the drill bed or the milling board or the milling table or something like that. So those are totally flat within 10 thousandths now. And I also figured out what was wrong with the level. And I dropped the level when we were making the last video and ended up putting a little bit of a dent in it, which I'm kind of bummed about, right here on the corner. So I had to go re-level it right there. But I'm not, it is what it is. But the rest of it is super flat within about 10 thousandths. And I now have a nice parallel to use, and I also calibrated it on Joe's level, so now it reads totally flat. You can see this table's a little bit off, and I'm pretty pleased with my little level now. It even has a vertical level also, so that'll come in really handy. I'll try not to drop it anymore. But just to show you, it's interesting when you have one flat, like for example Joe's surface plate over there. Once I've made one thing flat, I can then transfer that flat surface to other things. So now that I've made my level flat, and I've also made this surface plate flat, what I can do is I've put some Prussian blue on the plate here, and now you can see I can check my level, and it is totally flat. And I could do both sides, and let's see here. This is Joe's cuckoo clock project. Put a little bit more blue down here. Get some more ink down here. Check the other side. Joe's over there working on his pencil sharpener, making modifications to his pencil. There's the side that I scraped. You can see that it's accurate within probably 10 thousandths across the entire surface. There's a little bit of a light spot right there, but it is making contact, and it's a pretty flat surface. So this thing is totally flat on both sides, and it is parallel because I paralleled it on the surface grinder. So I did check it on the surface plate too. If I wanted to, for example, I could grab an indicator, and now that I'm working on a completely flat surface, I could indicate this. I'm not going to do it right now because it's difficult to do this one hand. I don't want to damage this indicator. Well, maybe I can do it. Let's see here. Yeah, there we go. So like, this is a 10 thousandths indicator, and I'm off the board a little bit over there, but you can see I'm within a couple, maybe 2 or 3 10 thousandths across here, but I'm kind of doing this inaccurately. But yeah, fun stuff. I got, now the benefit is I wanted to take advantage of Joe's surface plate to compare it to my surface plate, and now I've got some totally flat surfaces that are, I wouldn't say lab quality, but certainly within motorcycle machining quality that I can use as references now. If I'm doing cylinder heads or anything like that, I can use these as a reference to make something flat or compare to see if something's straight, for example. So very productive day here at Joe's. I got my